Hello, everyone. So I'm going to go over your final lab, which is your mobile lab. And as you know, you can find the mobile lab within your labs folder. And I have not actually created the assignment for it yet, but it's coming up soon. But let's go to the lab instructions. And want to go over the experiment with you just briefly. Now, what is the point of a mobile lab? Well, we want to talk about a moment. We want to talk about a moment. A moment is equal to force times distance. A moment is equal to force times distance. Now, for this particular lab, you're going to explore kinetic energy in a sense of your mobile, which is a hanging object, sort of like a chandelier. But you're not obviously going to create a chandelier, but you are going to figure out how to balance multiple objects as they are rotating, right? And you have to basically do this by using the moment force, right? And so if you come down just a bit, this is what the outline of your mobile will look like, right? It kind of looks like a a box diagram, so to speak. This is, but your mobile would look like this in a sense as well. So this indicates it's hanging from something, which would be your hand, so to speak. And then you have an object here with a certain weight, and every other layer will have to basically offset this weight here to keep it from to keep the weight from descending to the right or to the left. It's almost like a balance beam, so to speak. So what you're going to do is perform a calculation, right? You're going to pick an object and a weight over here, and then you're going to have to pick at a minimum 4 more objects. Or, I'm sorry, at a max. Yeah, I said it right, at a minimum. So I'm saying at least 3 levels. So if you're doing 3 levels, you're going to have, I guess, a minimum, not even a minimum. You could do, honestly, you could possibly get away with having 1 layer with 1 object, right? And then another layer with 1 or 2 or 3 objects. But the thing is whatever you put on this layer here is going to have to balance this layer in addition to the first layer, right? And so again, the calculation, force times distance. So how you're going to do this is you're going to put your weight here, whatever that equals, and you have to figure out how far from your axis it needs to be to balance this weight. So if you're going to do 1, 2, 3 layers, right, that's going to be setting that. So you're going to make this moment right here, force times distance. So if this is your axis, right, it'll be a certain distance, a certain weight. You multiply this distance times the weight of this object. And that's the moment you're trying to accomplish with the next 3 layers. And so if you use 1, 2, 3, 4 objects, so that's going to be 4 weights, right? And so obviously you could say, okay, 4 times the total weight, and then you solve for the distance. But then that would say, oh well, that's if I was only using 1 other layer. So you're gonna go total moment is equal to the total force times distance divided by 2 layers, right? So you're gonna have to divide those layers by 2. Now, it's easy to just go 1 layer at a time, but if you want to solve If you want to make it symmetrical, you can do it the way I said it. You can go, I know I keep rolling this up and down because I'm showing you I'm showing you the formula for calculating the moment. Um, but if you want to make it symmetrical like this one is, this is symmetrical. So you would basically use the same distance between these two layers, and these objects would have to be the same weight. But as you can see with this one, they broke it down in layer one and then solved for layer two and figured out the distance for half of this, right? And then they solved these two and they say, oh, well, these objects here probably weigh a little more than these objects because the distance between these two are different, right? So this object must weigh a little bit more than this one because the distance between the axis here and here is a little greater. So you just have to keep basically reiterating that formula, solving the distance from the object based depending on what weight you make this object. So you're gonna have to play with it a little bit in your experiment, but point of this lab is to see, not just see, but explore and also experiment with weights and distances in order to create a balance on your mobile. And so obviously I'm simplifying it for you, but do a little research so that you can understand truly how force works with distance and what a moment does exactly. So if I were to, those of you that haven't had physics yet, those of you that have had physics, you know exactly what it is that I'll, probably more or less what it is that I'm about to share when I go to my whiteboard. But it's the gist of this is for when you are balancing like a beam, so to speak, right? So if you have a cantilever beam, right, and then you're trying to figure out how much weight can I put on this that would allow this thing to bend. That looks horrible, but this is supposed to be like a dotted line indicating how it's bending, right? And you have this amount of displacement from here to here and from here to here, right? But anywho, it's basically you have a weight here, right, which causes this to bend. And you have a weight at a certain distance from your axis, which is the zero here, right? At your origin, rather, from your origin, 0, 0. And you have this distance at this weight, and you create this moment, right? And create that moment. And so you have your moment here. When you take the moment about point A, this was point A. And so, the purpose of solving for the moment is to, again, to determine how much bending this will do before it has permanent deformation, right? And so you may have to increase this thickness. You may have to maybe make it shorter, right? There's certain things you're going to do to explore, to and experiment with to determine if, using calculations also to determine how you need to manipulate this cantilever beam in order to make it safe. And you think about what a cantilever beam is. Well, you think about a balcony outside of your apartment. If you're on the second level and above, right? And so what they have to do to make this beam strong enough for your weight and even other weights of people, your chairs, things of that nature, and allow it to continue to balance. All right. So that's pretty much all I have for this experiment. If you have any questions, please let me know. But this is your last experiment for the semester. So I'm changing the due date. Initially, I have it due for the 23rd, but I'm going to make it due for the 30th. All right. Thank you.